G'day guys, got an interesting one here. Got an SD2200 and it got hit by lightning. Well, close proximity. Lightning hit a tree and the fellow said that sparks or something went on the ground and hit the coil, and he felt the tingles in his fingers. And after that, the detector doesn't work anymore. So yeah, I've got it on the bench here. I've got another one which I'm using as a reference because these things are so old. I think I've lost all my information on them. They're buried on another hard drive somewhere. But yeah, this is interesting. Anyway, I'll point out what this did. This is it was pretty cooked actually. It didn't do anything. It just sat there and made a continuous tone. But I'll probably use that if I can lift it up. This is getting some upgrades done at the same time, but I better take the wires off, the cables I mean. And because this is like so, it's really hard to work with. Where the switches are, all the wires are really tight, and I'll see if I can get it round to show. You probably want to close up, but yeah, I don't know if you can see in here. It took out the first amplifier stage, which is probably pretty typical. I put a AD797 in there. With these, I can't remember if it's actually a NE5534 or an AD797, but the AD797 is a much better device anyway. So I put a AD797 in there, and here it took out the comparator next to it, LM339. So I put a second hand AD797, because I've got a fair few of them kicking around in there. It came out of probably a 3000 or something. There it is, and yeah, LM339 comparator. It took that out as well. And if we can look up, I don't know if we can get round, I can show you what it did here. It's right next to these big capacitors here, so it's hard to see. But it blew the power supply up as well. And on here, it was acting very strange. So we had to, this device, I don't know if you can see it there, you got a ZTX688 here, just a N-channel MOSFET up the top there, and on here it's a NPN transistor, just a small one, BC547 or something like that, I think, from memory. And it actually blew that up. It took out hang on, where did it take out? Yeah, it it took out the emitter. The emitter part of it wasn't there anymore. It had a collector, base to collector, but no emitter. So I replaced that, and horrible place to get in and work on these because it's all bent. I'll see if we can get right in there if you can see it next to the capacitor there. But yeah. So after replacing all those bits and pieces, we can plug it in, and yeah, this, because I fixed it, the fellow wants it modified. So if I turn it on, oh, you can hear that. Obviously, we can't, I haven't got a cancel coil on it or anything like that, but we get a screwdriver and go over the coil. Yeah, she's all working. So yeah, don't let your detectors come in proximity to lightning. It's quite funny actually. Yeah, I was actually using this detector here as a reference because don't have a heart attack, people. But I'm going to show you. I'll show you something funny. Uh, yeah, I cleaned up my desk, and I've taken all the external hard drives off the computer, and yeah, I didn't have any reference material um, to fix the 2000. God, this is all over the shop. This thing. Um, this has got, look, it's got the wobbles. Oh, not to worry. Yeah. So basically, I just used another one. Just you know, poked and probed a couple of measurements there, and I went, aha. It's also well, basically, I needed it to find the comparator that was stuffed. Power supply is pretty straightforward, but yeah, it was a bit of a deeper dive. And anyway, fixed it. Probably modernized it a bit too, because like I say, I can't remember if they use an AD797 or a 5534. It's going to be the difference of probably 3 nanovolts better sensitivity or less noise, should we say? And same thing, actually, believe it or not. So yeah, less noise, more sensitivity. Get down closer to the noise floor. Get down a lot closer. If you lower the noise floor, you can hear more. So that's a good fix. There's someone sending me or sending messages. It's XJ from, yeah, XJ's I think, what is he now? Governor of Camagan over in the Philippines. So yeah, good day XJ and your old man. But anyway, um, this is all good fun. And as you can see too, I've actually take a photo. I've actually cleaned up the workbench, but because 2 detectors are on it and bits and pieces, it started going, you know, sideways. It just generates a lot of you know, scatter of parts and everything. It was completely clean, and yeah, out come the vacuum cleaner. Um, yes, yeah, BC 847C was the replacement part. So yeah, these are really good. These little containers. We're going off topic, I know, but because I put it there, people will probably say, "Oh, what's that container?" Okay, I got these from. You can get them from Target, or you can get them from um, what was it? I'm trying to remember. Kmart. I nearly said Big W, but it's Kmart. And just as a, I'll show you what they are. They're not that expensive. Like, I use these to put all my parts in, uh, because if you use drawers, you can have the whole place would be full of drawers. So I've got down to using these, and they come in a nice little acrylic thing. I think they're, I don't know, $6 or something. And if you want to, oh, I got these the other day. This is interesting. Try and buy 1 megahertz crystals. God, but have a look at these. They are 1 megahertz crystals, and we plonk those into the SD2000s to give them a really long set of pulses for big deep gold. They're very good at detecting really big targets deep. It's probably actually one of the best detectors for doing it, for looking for big gold. The old SD, lower the frequency, modernize it a bit, put in some variable gain, and it's a really quite remarkable detector considering it is so old. They're cheap and they're damn good. So yeah, with these crystals, it was quite interesting too. I bought these and I was very, very wary because they're so small. 1 meg crystal is normally a large crystal in a big can. And I said, oh, come on, they made a mistake, so I bought them anyway. And there's, yeah, there's quite a few in there. But the thing is, they're, for anyone out there who wants to know about crystals, you're meant to have parallel capacitance of the crystal calculated into your oscillator circuit. And most crystals are around about 30 picofarads capacitance, and these were 6. So I put one in an SD2000 and it told me, go away, come back another day. I'm not going to work in a million years, no. And it wouldn't work in that circuit. So I had to actually change the pattern capacitors on the circuit board. I think they could be 33 picofarads in there. And I actually dropped them down. I had to drop them down to 3 picofarads a side. It wouldn't work at 6, so I had to drop it down to 3 picofarads a side. So maybe it's a total of 6, but because they're in series, capacitance divide, so it's 1.5 in that regard. No, it's actually 3 picofarads per side, and it was iffy on starting up. So I changed all sorts of resistor values and things in the circuit, in the feedback, in everything to do with anything. I changed the value, it wouldn't start. And I said, come on a second, this is getting ridiculous. And I said, it's probably just because the crystal's such low capacitance. So I remembered something from years and years ago about with crystals, how they go into a harmonic relationship if you put 2 of them together on the same circuit. You think they'd all oscillate by themselves and make a mess. Well, actually, by putting 2 crystals in there and increasing the distributed capacitance to big grand total of 12 picofarads, it worked, and it locked beautifully on 1 megahertz. And actually, it makes it more accurate, believe it or not. So yeah, there's 2 crystals in there, and they actually self-lock to each other. So yeah, it works really well. So you can use these tiny little crystals. They're like a watch crystal. I mean, they are so small. I mean, if you can see in there, that's how small they are. They're really tiny. So yeah, well, I knew that you could get low frequency crystals because they make 32 kilohertz watch crystals in the same package. So if it works at 32 kilohertz, well, what's so hard about making a 1 megahertz one that small? So anyway, I took a gamble on buying these, and I thought I'd really done my dough until I came up with the old remedy of, well, obviously the circuit needs more capacitance. Well, stick 2 crystals across the same point, and away she goes. You can't do it with big spread of frequency. You can only do it with crystals that are cut for the same frequency, but they still might be a few hertz or hundreds of hertz off from an exact number, but they will lock together. As soon as it starts oscillating, it all, yeah, I was going to say, I suppose you could call it like phase locking, but it actually does. One will mirror the other, mirrors the other. It's interesting. So take that into account if you have crystal oscillators that will not work, and it's usually maybe the intrinsic capacitance of the crystal is too low for the circuit, or it could be the other way around, but I doubt it. Usually, if it's too low on the crystal, yeah, it gets a bit fussy. It probably wants to have a very high impedance CMOS device, be it a inverter or some sort of switching to get the thing up and going to make it oscillate. You could probably use some little tiny JFETs instead of standard CMOS or transistors or whatever. But yeah, well, the point is probably don't buy 6 picofarad crystals in the first place. But yeah, we got a jail-free card with that, so we did by just using 2. So it's only for the SD 2000s. The rest of them don't use that. The rest use LC oscillators. And to this day, they still use LC oscillators. And we all know why. It keeps the phase noise down. Which you don't want spurious noises, sidebands generated. If you multiply off your base crystal frequency, or you even divide it down, you don't want sidebands, even though they probably come in closer if you dividing down. But all noise sources in a detector degrades the whole thing, so that's probably why they don't use digital means for critical timings. You don't want something sitting there doing this where an LC oscillator's got a very slow drift and detector doesn't care less. I mean, who cares? As long as it's not close in jitter on your switching for like transmitter turn off, receive, turn on, and dead times, and all sorts of you detecting on the decay curve and so forth. You don't want jitter there, just destroy it. The detector or performance will go out the window. So anyway, all good. This was all about a detector hit by lightning, and I went on to SD2000s. Well, fancy that. You should come to expect that by now. By the way, the Gold Monster 2000's out running around all over the place, so I've been told. And just to upset everyone's apple cart, the latest modification that I did on a GM 1000, I only showed half the modification here. I hadn't finished it off. I hadn't gone onto the back of the board. And anyway, the customer wanted it back, and David finished it off and did the test. I gave him the test jig and everything, and I said, here, do the rest of it and tell me. And he actually got me on Messenger, and he said, it is so damn good, it's not funny. He said, absolutely massive improvement, and less noise, and greater detection depth. So there is, don't throw your Gold Monster 1000s out just yet. But yeah, I was having a bit of a I'm getting a GM. Someone's going to drop a GM 2000 in, and they're 1000. I want the 1000 modified, and they want to know if there's anything I can do to the 2. So if I can, what I do to the 1, I can do to the 2. I'll do that as well. I said, well, your 2's still in warranty. He doesn't care less. Prospectors, anything for an extra couple of millimeters or more. It's quite it's just nature of the game. Anything for that little bit of extra depth. Apart from that, all good. And anyway, I better put these, or finish this one off and put them back together. Because you know what's happened, don't you? The shelves here are full. No, they got the yellow Durkins on them looking at me, so I can't show. But do you know what a Durkin is? A Durkin is, you call something a Durkin if you can't remember what it's called. Okay, labels. So yeah, they got labels on them. So Durkins. You ever heard people say, "Oh, can you get me the Durkin?" So from now on, anything I don't recall the name of straight away, I'm going to call a Durkin. So be wary of that. Hey, can you get the Durkin for me? Yeah, crazy. But all good fun. There was something else I was going to mention as well, but there was something. What was it? It was something interesting. Oh, escapes me. I've got to go and have a look at what I've been looking at. Been doing a lot of study, and I mean a lot of study on ADCs of all things, and people are going to go, oh God, why do you want to study that? Because you got to study it. If you're doing any design work, you'll know why you want to study it. People just take them as a, they treat them like just like a block item. Bang, in the circuit it goes, without any regard for anything else, and that's a bit of a bad thing to do in some circumstances, especially if you're going to apply it to anything that's low noise. We used to always use Delta Sigma ADCs for low noise, but the SAR ones now are really, really good. There's some really good ADCs out there, really, well over 100 dB signal to noise ratio through all their internals and built-in digital filters and all sorts that improves noise figures more. Yeah, there's a lot of good stuff out there, it really is. So I've got some more boards made over in some place and they'll be coming in soon. I've got 2 boards coming, and hopefully I can fire those up and do a demo on something that people will be very interested in. I keep telling you things are coming. It just takes time. If I could actually dedicate all my time to doing a project, right, it would be really fast. But at the moment, like I had an audio project, which is really, really good. And I'm not joking. I built the boards up probably 8 months ago. Realized I put something on. I got the outputs ran the wrong way in the board design. It could go either way, but yeah, typical. I wasn't paying attention. Probably had someone on the phone annoying me while I was doing it on the doing the board design. This is what happens if you get people come and talk to you. You'll go, oh, that goes there and that goes there and that goes there, and you'll complete your stuff up. Yeah, I got the new boards in. I built up a prototype, well, actually the unit, and I know it's correct, but I haven't even fired it up, and it's been here for over 2 weeks. I just don't get the time, and this is really good for every detector out there, every detector on the market. It's really good. People are going to love it, but I just can't get it done. It's really funny. Oh, and there it is. It's in the that's how big it is. I told you, colony of ants live in these things. So it's got a little box, and yeah, it goes in there, and when it goes in there, it's going to get a nice hard layer of an impervious conformal. We will call it a conformal coating. No, it's conformal epoxy. Well, actually, it's not really epoxy. It's something else, but you can't eat away at it. It'll destroy everything. So everything we're doing, everything from now on is going to be in modules. We're not going to do bare boards and stuff and whatever. So it's all going to get locked up in modules, and that's the name of the game. It's better for heat dissipation and just overall control, and we can test it as a a unit, and yeah, if it ever fails, well, we can send you a new one. You can either, if you're technically competent, you can just desolder and solder the new one in, or send it back and we'll put a new one in. But it shouldn't fail. We've been doing this long enough. Things don't fail for no reason, and we don't do things to make them fail. Yeah, unless they get hit by lightning like that poor thing there. But anyway, that's enough waffle. I try and make these things probably go for about half an hour. So I do a bit of infill. If it's too short, usually it's, it's not interesting. So we go onto a little drift onto other subjects and put a bit of fill in there. So after 15 minutes, if you don't want to hear the waffle, just turn off. If you want to hear all the waffle and all the extra stuff, listen in. Simple. Anyway, catches, I'm out of here.